On this second part of lesson 9.4, we're going to focus on using completing the square to write the vertex form of a quadratic. So first of all, let's review what that looks like. Vertex form of a quadratic is when it is written in this format, where H and K are the vertex. A is still the leading coefficient that tells you which direction that parabola opens, upward or downward, if it's wide or narrow. But the advantages to vertex form is that we can see that vertex ordered pair right away. And the reason why we can use completing the square to write vertex form is because hopefully at this point, you know, completing the square creates a perfect square that we can then write in a power format. And if you notice, that is always present right here in the vertex form. It's always that binomial to the second power. So you have a perfect square written in power form right here embedded in that vertex form. So for that reason, this completing the square process will be a big part of being able to write standard form to vertex form fairly quickly instead of having to go through all the steps of finding the vertex and then plugging in. So this particular process is especially simple if you have an a value of 1. Just like with completing the square, we want a to be 1. So if that's already in place, then that's a huge advantage here. So when we start with number 1, we're going to go through very similar steps as what we did in the first part of this lesson, completing the square. If there's a constant here that is not creating a perfect square in our trinomial, we want to get it out of the way, just like we did before. So when I look at my equation, x squared plus 6x plus 10, that 10 is not a perfect square. It's not creating a perfect square trinomial, so I'm going to move it out of the way. And if I do that on one side, I need to make sure I do it on the other side. Now, the last time we did this, on the previous part of this lesson, there was a number here and we could actually solve this. This is not equal to anything. We're not solving today. We're just reorganizing it to vertex form. So what I have is a y, and if I subtract 10, I'm just going to leave that as y minus 10. That's going to be temporary. We're going to fix that in just a bit, but not right now. So we're going to move that 10 over, and on this side, I'll have my x squared, my plus 6x, and my little blank space here that I'm now ready to complete the square with. Okay, so just like we did before, to complete the square, we'll take this middle term, that number 6, and we'll do 6 divided by 2, and then we'll square that answer. So 6 divided by 2 is 3, 3 squared is 9. So we know that to complete the square here, what we're going to want to do is add a 9 here. And again, if we do it on one side, we have to do it on the other. So if I add 9 on this side, I want to make sure I add 9 on the other side. Okay. So here I now have y minus 1 is equal to, and then I have this perfect square trinomial that I can rewrite as a power. And in fact, that's the whole point of creating it, is that I can now rewrite this as just x plus that 3 and write it in power form. Okay, we're actually almost done now. All we have to do now, like I promised, is move that 1 back. So we added 9 on both sides, that became minus 1. Now we move it back to this side so that y is isolated again. And this cancels, and so now I have y equals, I have my perfect square trinomial here as a power, and then that plus 1, and guess what? That is the vertex form of that quadratic. This right here tells us that a is 1, is a positive 1, which tells us our parabola opens upward, and the vertex is at -3, 1. So it says find the max or min here. The vertex here would be at -3, 1. 1 would be, in this case, the minimum, because this is a parabola that opens upward. So that vertex would be down here. So that means the lowest value of that vertex is 1, since that's the y-coordinate of our vertex. So this would that would be equal to 1. There it is. Okay, and if they had asked, which I feel like we should have, the vertex would be at -3, 1. So let's go ahead and add that in there just in case. Okay, let's try the next one. Similar, again, if that a is 1, it really does make the game pretty simple. We're going to rewrite this in vertex form by completing the square. So the first thing I'll do is move that 7 out of the way because that is not creating a perfect square like I want it to. I'm going to leave that 7 next to the y for just a moment so I can complete the square. Okay, to complete the square, I'll take this middle term, divide by 2, and square that answer. So if I do -2 divided by 2 and square that answer, that's really -1 squared, which is just 1. So to complete the square here, I'm going to add a 1. If I add a 1 there, though, I have to add a 1 over here as well. So now we've got y plus 8. And on this side, this is a perfect square trinomial that we can rewrite as a power. That -1 in here is what goes inside our parentheses. So we know that that perfect square trinomial can be rewritten as a power, x minus 1 to the second power. And then my last step is just move that 8 back to the other side. And you are in vertex forms. So basically get that y re-isolated, and our equation looks like that. And that's the vertex form of that parabola. And if they ask us, this has an a value again of +1a, which means it opens upward, and that means that the vertex happens to be a min. The vertex would be this h and k, so our vertex here would be the opposite of what I see there and exactly what I see there. This is all review. And then it would be a min of e, that is -8. Remember, the y-coordinate of the vertex is always your max or min. Okay, so that's all the information that we needed there. Vertex form, the vertex is always good to see, and then what your minimum value was. All right, so then let's talk about when a is not a 1, because this is where it gets interesting. You're really going to want to pay attention. It's not necessarily hard. You just kind of have to pay close attention to where a few things are going to come from here. So in this particular case, we have a negative here that we need to deal with this negative. Okay, so what we're going to do is, first of all, we're still going to move that 3 out of the way. So let's start by getting rid of that c value and getting it to the other side like we have been. So now I've got y minus 3 is equal to -x squared plus 4x. Now this is an issue, right? We know that in order for us to really be able to complete the square, this has to be just a +1. I can't have that negative there. So what we're going to do is we're going to factor, I'm going to leave this alone, and over here I'm going to factor that -1 out of those two terms, okay? So if I divide out that -1, I get x squared, and here I'm going to have a -4x. It's going to change both of those signs, okay? And in here is where I'm going to complete the square, okay? Now this part's going to be pretty normal, so I factored out that negative so I wouldn't have to deal with it. I now have this trinomial, and this is where I'm going to complete the square. I'm going to take that b value divided by 2 and square that answer. So that means -2 squared, which we know is 4. So I know that adding a 4 inside of this parentheses is going to complete our square. Now here's the part you got to be careful about, okay? I added 4 on this side, inside of this parentheses, and whatever I do to one side, I have to do it on the other. However, okay, this is going to feel weird the first time, but here's the deal. Even though it looks like I'm adding a 4, I'm doing that inside of this little sort of environment inside this parentheses that really has this outside. And if I were to distribute that negative, I would realize that that actually is a -4. It looks like a +4 because I've temporarily factored this out this way, but it's really a negative times all of this quantity. So if I were to distribute that, I have to realize, oh, that's really a -4, even though it looks like a +4 right by itself here. I really have this -1 that's outside being multiplied. So this is really a -4. So when I do it on the other side, I need to make sure that I do a negative. So the big idea that's kind of a little interesting and you got to keep up with is that whatever this a value that you kind of factored out, you need to multiply that by that c value that you're adding in. So in this case, that -1 that's on the outside needs to get multiplied by the value that you just added And that's what you're really introducing, even though it doesn't look like it here. That's what you're really introducing as a -4. So you got to make sure you do a -4 on the other side. Okay, so now that's going to be y minus 7. Oh, sorry, y minus 7 on the right side there. And then I have this negative on the outside. I have a perfect square that I can rewrite as a power. And now all I have to do is add that 7 back to the other side. So this is going to be y equals, you have the negative on the outside, x minus 2 squared, and then plus 7, and that is in our vertex form. There's our a equals -1, just like before, and there's our vertex right in here. This is the vertex form of that particular parabola. And then that also would mean, guys, that the vertex would be 2, 7. And since this is a downward opening, it has a max at 7, which is the other main topic. All right, let's try one more like that just to kind of get the hang of it. I know that it's a little different. So let's take a look at number 4. First things first, let's move this. Oh, actually, no, that negative is going to mess it up. I was going to say, oh, it's already a perfect square, but it isn't because of that negative. So let's move that forward to the other side. So we get y minus 4 is equal to that negative x squared minus 4x. We cannot have that negative there, so the next step is to factor it. That changes our signs, and then we can complete the square here. To complete the square, we'll take this middle term divided by 2 and square that. So 4 divided by 2 squared is just 2 squared, which is just 4. So I'm going to add a 4 here. But even though it looks like I'm really subtracting or introducing a negative. This is really a negative all the way across. That negative would be distributed. So it's really a -4. So I need to make sure I do a -4 over here. Okay. So now we've got y minus 8 is equal to negative, and then this perfect square can be rewritten in power form. And then last but not least, we move the 8 back to the other side, just like that. And so we get y equals, there's our negative, x plus 2 to the 2nd power plus 8. And that is the vertex form of our parabola. This opens downward once again, so it's got a max. And so if the vertex is -2, 8, then my max is at 8. Okay, and if it had asked us for the vertex, it would be at -2, 8, and that's always good to know. All right, so let's see. So hopefully that feels more comfortable on that particular problem. And let's see if there's any other topic or any major points I want to make on that one. All right, let's try it here with a word problem then. If you look at number 5, the cost C in dollars to produce X items is given by that function there. We want to write the equation in vertex form using the method of completing the square. So we're going to do exactly what we did in these previous problems, but we're doing it with a word problem. So this is our equation. We've got the cost is equal to 0.2 x squared minus 10x plus 650. Okay, so first things first, let's go ahead and move that 650 to the left side so we can start the process of completing the square. So I've got C minus 650 is equal to this. Okay. And then we have the predicament of that coefficient there. This time it's not just a negative, it's actually a number. We still need to factor it out because the only way we complete the square is if there is not a number here. So we're going to factor out 0.2. We're going to divide a 0.2 or a 2/10 out. So if I divide that here, I just get x squared. But if I divide -10 by that, I actually get -50x. So here is kind of this artificial environment is where I'm going to complete my square. So I'm here now. I just factored out that 0.2. And I'm in this sort of little imaginary space. I'm going to go ahead and complete the square. So I'll take this here in the middle. I'll divide it by 2. And then square that answer. So negative 50 divided by 2. And then I square that answer. So that's negative 25 squared. Happens to be 625. So that is what I want to introduce here. Now it looks like a 625, but it really isn't, right? It's 0.2 times that. And so just remember, just like we had to take that negative into account, you want to multiply these two things together and then use that result as what you actually do on the other side. So if we do that 625 times 0.2, I'm grabbing my calculator here, that's going to tell us what we do on the other side. So 625 times that 0.2, that's 125. So really it's a 125 that I have to do over here, which would be the product of that, because that's what I really have. Hopefully that's making sense. And when we get that difference there, we get 525. So we got C minus 525 is equal to 0.2 times this, which I can now write as a perfect square power. And now all we have to do is move the 525 back. So C ends up being 0.2 x minus 25 inside of our parentheses. And then when I add that back, it's going to be back to a positive 525 on this side. Okay, and that is a vertex form of the same equation. And it tells us what A is, it tells us where the vertex is. We know this is opening upward, so that is a minimum. So all of that good stuff. So there it is. Then it says how many items should be produced to minimize the production cost. So again, this represents a cost based on how many items you produce. So if it's this parabola that opens upward, we want the cost to be at its lowest point. So we basically want to know what is the min. That's what this is really asking. What is the minimum cost in this particular relationship, right? So if we want to minimize it, we want to stick to that minimum. And it wants to know how many items, which is our variable. So, I mean our x. So if we think of this as the vertex, we know our vertex is at 25, 525. So this is how many items you would have to produce for the cost to be lowest, if that makes sense. So it would be, you would want to sell 25 or produce, 25 items for you to get the lowest cost, which would be 525. Okay, and what is that minimum cost? 525, right? So it's basically just that vertex represents the number of items you'd want for the lowest cost, because that's what it would represent on the parabola. Okay, all right, let's take a look at the back page here. Got a couple more just to practice, and then we'll finish off with that word problem. So try number 6 on your own and see how that goes, and take a pause and then we'll check it. Okay, so hopefully you tried that one. The first step is to move the 7 to the left. So we've got y minus 7, that is equal to, let me actually check something to be sure. If we have, oh yeah, because this one has a negative. I was going to say this looks pretty familiar, but it's because of the negative. All right, so we move that 7 to the other side. That leaves us with negative x squared plus 2x. We don't want the negative there, so we factor it out, and we end up with that, where we can now complete the square. To complete the square, you would have taken this negative 2 divided by 2 and squared that answer, which is just negative 1 squared, which is positive 1. So we would have a positive 1 right here. And even though it looks like a positive 1 inside of this parentheses, it's really a negative 1. So I make sure I do a negative 1 on the other side. And that gives us with, that leaves us with y minus 8. And on the other side, we're ready to create that perfect square power, which looks like a negative on the outside and then x minus 1 to the second, and then you just move the 8 back. So if you add the 8 back to the other side, the vertex form here is y equals negative x minus 1 to the second plus 8, and there's your vertex form. And the vertex of that parabola would be at 1, 8. And this one opens downward, so that would be a max value at 8. Okay. That would be everything you'd want to know about that parabola itself. And vertex form we already knew was really helpful. Try number 7. Try number 7 on your own and see how that one goes. Okay, so when you tried this one, hopefully you move that 22 to the left. And we get y plus 22 is equal to 2x squared plus 12x. We don't want to have anything here, so we have to take care of factoring that 2 from that group before we start to complete the square. So I'll factor the 2, that leaves us with x squared plus 6x, and I'm ready to complete. So this is a 6 because I divided that 2 out, right? So to complete the square, we'll take that 6 divided by 2 and square that, which is just 3 squared or 9. So I want to add a 9 here, but again, it appears like a 9, but it really isn't. It's an 18 because this entire quantity is being multiplied by 2. So even though it looks like a 9 in the parentheses, it's really 2 times 9, which is an 18. So on the other side, I want to make sure that I respect and honor that with that 18 there. Okay, so I've got y plus 40 now is equal to 2, and then in parentheses we'd have the power form of this, which would be x plus 3 to the second, and then we would move that 40 back, and we would be done and have this in. The vertex form of this parabola looks like this. There's our a value. It's a narrow positive upward with a vertex at -3, -40. Since it's upward, that is a min at -40. Okay. All right, we will finish number 8 in class together, and that completes our conversation about using completing the square to write vertex form.